Assalamualaikum and hi everyone. Welcome to topic 8 correlation and regression. Before we start, let's go through about what you will learn in the last topic for AM025, which is topic 8. First of all, there will be subtopic 8.1 linear correlation. Under linear correlation, you need to find the Pearson product moment correlation coefficient, which is denoted by R, and then you need to interpret the value of R. After that, there will be 8.2 simple linear regression. Under 8.2 simple linear regression, you need to find the equation of regression line, which is y hat equals to a plus bx, and then you need to determine a and b in the regression line using least square method. After that, you need to interpret the value of a and b in the regression line. More than that, you need to determine the coefficient of determination denoted by r squared. Lastly, you need to interpret the value of r squared that you get. So, these are the lessons that you will learn in this topic. Please prepare your pencil, your calculator, and your module. Stay focused and aim A for maths. Topic 8 Correlation and Regression. Lecture 1 of 3. Subtopic 8.1 Linear Correlation. At the end of the lesson, you should be able to 8.1a use a scatter diagram to describe the relationship between two variables. B. Solve and interpret the Pearson product moment correlation coefficient, which is denoted by R. First of all, let's recall what are the variables in this topic. As you remember, from your graph paper, you will have the x-axis and the y-axis. For the x-axis, it is referring to x variable. For the y-axis, it will be y variable. For x variables, we would say that it will be our independent variable. In other words, it is the explanatory variable. For y-axis, it is the dependent variable. In other words, it is the response variable. The explanatory variable is the cause, whereas for dependent variable, which is the response variable, is the effect from the cause. Let's look at example for independent variable and dependent variable. For independent variable, let's say we have temperature, and then for dependent variable, we have sales of ice cream. From here, if you can relate between these two variables, between temperature and the sales of ice cream, what will happen if temperature rises to the sales of ice cream? Because the independent variable is the one that caused the problem, whereas for dependent variable is the one that will get affected. So, if you can see here, as the temperature increases, the sales of ice cream will increase as well. It would make sense if you can relate like this. When the temperature increases, the desire of people in order to eat something cold is increased. So that's why increase in temperature, the sales of ice cream will increase as well. As a conclusion, we may write like this. Temperature may affect the sales of ice cream. Let's proceed with part A, scatter diagram to describe the relationship between two variables, which is the x variable and y variable. First, A scatter diagram shows the relationship between two variables measured on the same individual. Secondly, each individual in the dataset is represented by a point in the scatter diagram. Thirdly, the independent variable x is plotted on the horizontal axis and the dependent variable y is plotted on the vertical axis. The examples of relationships are the first one, your price of car maybe depend on your income. So the price of car will be your y variable and then your income will be the x variable. Secondly, your expenses may be determined by your salary. Which one is your y variable and x variable? The expenses will be your variable, whereas your salary will be your x variable. Thirdly, the number of births in a country can be used to determine the number of population. From here, you can see that the number of births may affect the number of population, which means that the number of births will be our x variable and then the number of population will be our y variable. Next is about the different type of relationships. First, you will have the positive relationship. Second, negative relationship. Third, no relationship. If you can see here, these are the examples of scatter diagram where you can see the points are scattered everywhere. Nevertheless, positive relationship, negative relationship or no relationship, the points are scattered like this. That's why these are called scatter diagram. For the positive relationship, if you can see, the trend would be as the x increase, the y increase as well. For negative relationship, the trend will be as x increase, the y will decrease. For no relationship, we cannot say x increase, y increase or x increase, y decrease because the scatter point is everywhere. So the trend cannot be determined. From the scatter diagram, we would know about whether there is any relationship between the variables. B, whether the relationship is linear or non-linear. C, whether the relationship is positive or negative. Next, let's continue with part B. Solve and interpret the Pearson product moment correlation coefficient. First of all, let's see about correlation first. Correlation is a statistical measurement of the relationship between two variables. So in this case, we will discussing about the x variable and the y variable. For example, we have as the temperature went up, the sales of ice cream went up as well. The next one is coefficient of correlation, which is denoted by R. What is coefficient of correlation? Coefficient of correlation is a numerical value which measures the strength or degree of the relationship between two random variables, which is given by R equals to Sxy over square root Sxx times Syy. What is Sxy, Sxx, Syy? So these are the formula in order to find Sxy, Sxx, Syy. For Sxy, it is equals to summation of x times y minus summation x times summation y over n. Whereas for sxx is equals to summation of x squared minus summation x in bracket square over n. For syy is equals to summation y square minus summation y in bracket square over n. N is the number of paired observation. If you can see the pattern of SXY, SXX, and SYY from the formula, it is just slightly different between them. For summation XY is for SXY. For SXX, the summation will be summation X square. For SYY, it is a summation of Y square. If you can see the pattern or the difference between SXY, SXX, and SYY, you can remember this formula easily. The correlation coefficient has values varies from positive 1 to negative 1 inclusively of both values. In other words, we will say that the modulus R less than 1. For linear correlation R, the interpretation of the values would be, firstly, we would say that the correlation is perfect linear if the value of R is positive 1 or negative 1. Whereas, we would say that the relationship between X and Y is strong relationship if the value is 0.8 to less than 1. For moderate, the value would be 0.4 to less than 0.8. For weak relationship, the value is more than 0 and less than 0.4. Lastly, if the value is 0, which means that X and Y has no relationship. For a better understanding for you, in order to define the value of R, let me show you a picture of number line. So here, if you can see, if the value of R is 0, it shows that there is no relationship between X and Y. Then, from 0 to the right hand side, it will be defined as positive side. Whereas, from 0 to the left hand side, it will define for negative linear. Okay, then if you can see here, from 0 to 0.4, the value will be defined as weak positive linear. Whereas for 0.4 until 0.8, the value is defined as moderate positive linear. And for 0.8 until 1, the value is defined for strong positive linear. It will be the same as the negative side, where for value 0 until negative 0.4, it will be defined as weak negative linear. From negative 0.4 until negative 0.8, it will define as moderate negative linear. And from the value negative 0.8 to negative 1, it will define as strong negative linear. Then, the value that you get, you need to interpret it. So, the interpretation of R would be, there is a, here you need to choose whether your R gives you the definition of perfect or strong or moderate or weak or no. So, the colored one is the one that you need to choose. The next one, where you need to choose whether the value of R gives you positive linear or negative linear. And then, you need to write linear relationship between. Here, you need to define your X variable, and here, you need to define your Y variable. So, these are the scheme in order for you to interpret your R. Example 1. The following data indicates the level of sales for 10 models of pen sold by a particular company. The sales together with the selling price of pen are given below. Calculate the coefficient of correlation and interpret your answer. Give your answer correct to 4 decimal places. Just before we start, please watch and learn on how to use your calculator for this topic. You may scan this respected QR code to watch the video about it. If you are already done, let's continue with the examples. Let's list out all the summation that you get from your calculator. Your n would be equals to 10 because of 10 models of pen. The summation of x is 1 for 0.5. The summation of y is 193 and the summation of x squared would be 2723.75. Summation of y squared is 4489 and then the summation of xy would be 2087.5. What you have to do is to list out all the summation that you get from your calculator. After you list out all the summation from your calculator, then you need to know what are the formula involved in your question. The question asking for the coefficient of correlation denoted by R. Okay, and then you have to interpret your value of R. The formula of R is R equals to Sxy over square root Sxx times Syy. The formula for Sxy, Sxx, Syy are here. So you have to find Sxy, Sxx, Syy. Let's start with Sxy. Sxy equals to, just put all the values in the formula, so you will get 2087.5 minus summation x is 1 for 0.5, summation of y 193 divided by 10. Then just press your calculator. You will get your Sxy is equals to negative 624.15. And then you need to find Sxx. Sxx equals to, just put the values that you get into the formula. You will get 2723.75 minus with 1 for 0.5 square over 10. Just press your calculator and you will get your Sxx is equals to 749.725. The next one is your Syy. Syy is equals to summation y square 4489 minus with 193 square divided by 10. Press your calculator and you will get the answer. Syy is 764.1. Then just put all the values that you get Sxy, Sxx, Syy into the formula of coefficient of correlation. R is equals to negative 624.15 divided by square root of Sxx is 749.725 times with 764.1. Okay, and then just press your calculator correctly. You will get your value of R is equal to negative 0.8246. So this will be your value of R. The next part is you need to interpret your answer. But before that, please ensure that your answer is correct to 4 decimal places. So the interpretation of R would be, there is a strong negative linear relationship between the price and the sales. Why the interpretation is negative? Because here we have negative value. That's why it said negative linear relationship. And then the value is negative 0.8246. From the scale just now, we can see that this will be strong negative linear. In other words, we would say that selling cheaper pen will increase the level of sales, which means that as the price of pen decreases, the sales of pen will increase. And this example is about inverse relationship. Let's continue with example 2. The following table shows the annual profit obtained by 8 small industries, which referring to our value of N is equals to 8 for a particular state versus the amount invested. Different from example 1. From the example 1, we already know what is X and what is Y. For example 2, the question didn't state about X variable or Y variable. So here, firstly, you need to define your X and your Y. From the statement, it showed that the annual profit obtained, which means that the amount invested will affect the amount of profit. So, from here, we know that the annual profit will be our Y variable, and then the amount of invested will be our X variable. So student, please take note. You need to define your X and your Y firstly. If not, the value of the summation that you get from your calculator will be wrong. And then the question asks you to find or to calculate the coefficient of correlation denoted by R and interpret your answer. Give your answer correct to 4 decimal places. First of all, list out all the summation from your calculator. Let's substitute N is equals to 8. And then you will get the value of the summation would be equals to, for summation X is 263, summation Y is 386, summation X squared 9195, summation Y squared is 19,242, summation XY 13,245. And then please remember the formula for R is SXY divided by square root SXX times SYY. And then the formula for the respective S is here. So let's find for SXY. SXY is equals to, put the values inside the formula. You will have such that 13,245 minus with summation X 263 times 386 divided by 8. Press your calculator correctly, you will get your answer 555.25. And then proceed with SXX. SXX is equals to 9195 minus 263 power of 2 divided by 8. Press your calculator. You will get the value of SXX is equals to 548.875. The next one is SYY is equals to 19,242 minus 386 power of 2 divided by 8. Press your calculator correctly. You will get the answer for SYY is 617.5. And then the formula for R is equals to the value of SXY 555.25 divided by square root SXX 548.875 times with 617.5 is equals to 9537. So this will be your value of R, correct to 4 decimal places. Don't forget to interpret your answer. Your answer would be, there is a strong positive linear relationship between. So here you need to define your X. Your X is investment and your Y is profit. As a complete conclusion, there is a strong positive linear relationship between investment and profit. In other words, increase in investment will increase the profit.